Okay, hey folks, how are you? Today is Unit 5, Day 5. We have, continuing on with our logarithms, we have a topic that's a little bit challenging, but we're going to do our best to make it very straightforward, and I'll just stick to the basics so you really get like the nuts and bolts of it, and then we'll continue and kind of expand on it in class if we have to. Today our topic is called the log laws, also sometimes known as log rules. And there are 3 of them that we're going to learn about, memorize, and then apply. The first one is called the product law or product rule. For the product rule, the idea is that if I have the log of 2 things that are being multiplied, log of A times B, that is equal to log A plus log B. Rule number 2 is the quotient rule. Quotient, remember, means division. So again, here, if I have the log of A divided by B, it's the same as log A minus log B. And then our last one, number 3, is called the power law or power rule. If I have log A raised up to the B, that is equal to B times log A. So again, these 3 you will need to know, have memorized, be able to work with. And an easy way to remember them or to kind of think of them is remember when you're multiplying like bases, what do you really do with the exponents? You add, right? When you're dividing like bases, you subtract. And when you raise a power to a power, double exponents, you end up multiplying those numbers. So the idea is that since the word log just means what is the exponent, logs are all about exponents, log and exponential we talked about last time. That's why these rules are as they are, because of those things that you already know. You know when you multiply like bases that you add the exponents. Well, since the word log is all about the exponents, that's why if I do them separately, I'm adding them. If I put a log by each, I end up subtracting when this original thing was division. And then this power to a power, the B comes out. You could just write B log A. You don't have to put the times symbol there. But I just did that so to illustrate kind of what's what. All right, so they can ask you to apply the log rules and pull something apart and expand it, or they can ask you to work the reverse way and put it together using the log laws. So let's just use some examples and I'll show you what I mean. Example 1, log of PQ all over 2. The directions would say, using the log rules, expand, or write as a sum and difference of logs, or something like that. The idea is that I've got this one blurb of stuff, P times Q all divided by 2, and I want to expand it out using the rules, and there's more than one rule going on. So I would start with this first idea that anytime you have division, that is the same as subtraction. So I'm going to rewrite that as log PQ minus log 2. And I'm not quite finished because PQ are now showing multiplication. So again, anytime there's multiplication, you pull it apart and put addition between that. And that would be it. It's finished. That's my answer. The only thing you might want to do is put this in parentheses to indicate that that was on the top. It would not actually be required here. You get it correct if you didn't leave the parentheses, but usually I parentheses the top or the bottom, depending. All right, example 2. It's just log of radical x. Well, remember, a radical is the same as raising this x to a power of 1/2. This is a really important fact that anytime you see a radical, it's just like a 1/2 power. We talked about that in day 1 about the root and the exponent business. And now this is an application of Rule 3, the power law. Anytime you have something raised to the power, it's the same as bringing that 1/2 out in front. So my final answer here would be 1/2 log x. Because that exponent should never be up there, it's always going to drop down and be out in front. All right, example 3. Example 3 asks us to find log of a cube root m divided by n. And you can probably tell that these can be pretty simple and straightforward, or they're going to be real complicated. This could get real complicated under here. Anytime you have a radical or a cube root or a fifth root, I would right away switch that into its exponent. So my first step would be m divided by n raised to the 1/3. Recognizing that a power of 1/3 is the same as taking a cube root. Now this is law number 3, the power rule, so that 1/3 as an exponent drops down out front and becomes times, so it's 1/3 times log m divided by n. And then this right here is the quotient rule. The quotient, when I'm dividing, I'm going to switch that into subtraction. So it's 1/3 of log m minus log n. But again, I'm not quite done because the m and the n were both underneath the cube root. All of that was being cube rooted, so you either need to apply those parentheses like that, or I would also take 1/3 log m minus 1/3 log n with it distributed out. Let's try a couple examples working in the other direction, and then I think you have some little bit of practice to go. All right, so here's example 4. Example 4 says, suppose you have 1/2 log r minus log s. Now they're giving you this expanded version like we just had up in that last example as our answer and asking you to combine it into a single. So the directions here would probably say express as a single log. Express as a single log. So there's a bunch of stuff going on. You see the subtraction and you see the 1/2. My first step is anytime I have something out front, I'm working now backwards, that's going to pop up as an exponent. So line 1 would be log r to the 1/2 minus log s. R to the 1/2 is the same as doing a square root of r. And then one more thing where it's showing subtraction, if I want to combine them, I'm going to combine them and make it division. So that's your final answer, square root r over s. There should just be one word log at the end. Example 5, let's go again and I'll show you at least one more. Not sure after that, maybe one more, we'll see. Example 5, I've got 2 log x minus log j plus 1/2 log k. And again, you can already see that they can get complicated. Sometimes students can do more than one step at a time. I'm going to show you every step, and if you want to combine a couple, that's okay. But I would start with the idea that anything is out front needs to back up as an exponent. That's going to go up, and that's going to go up as a power. This one didn't have one. So when we're working in the reverse order, the power laws go up first. That power of 1/2 is the same as a square root, so I'll get log x squared minus log j plus log rad k. I'll take care of what's in the parentheses next. Since it's showing addition, when I combine it together, I'm going to write that as multiplication. And then again, one more step. Now it's showing subtraction. I'm going to put those together actually with division. Just the word log once, and it's x squared over j radical k. And that's your final answer. Let's do one more example of one more kind of thing. So we had a single log like this and we pulled it apart. We had something kind of pulled apart and we put it back together. Those are 2 examples. This last one, example 6, you can put a star by it if you want. We'll need to look at this again when we come to class, but I still want you to have seen one. This is a little bit different. Also something they often do on the Regents, of course, right? If log A equals 2, And log 3, whoops, log b, sorry about that, b equals 3. Find the value. It might say find the numerical value of log rad a over b cubed. So basically I want to do the same thing. I want to expand this apart into a sum or difference of logs, and I don't want to do these substitutions till I'm all finished. So all we're going to do is expand this out like we did those first few examples. I always start with this division first. Division is the same as subtraction. So my first step would be to pull that apart, but change it to subtraction. Anytime I've got a radical, it's like a power of 1/2. Any of those exponents that are up high because of the power law will come down out in front. So this will be 1/2 log A minus 3 log B. And once you're completely finished and it's totally expanded, now I'm going to go back and make a substitution. Log A is the same as 2. Log B equals 3. So right here I'm going to put 2. So it's 1/2 of 2 minus 3 times 3. Half of 2 is 1 minus 9. My answer here is -8. So you don't try to substitute at this early step. You just expand the whole thing and pull it apart and substitute at the end. Okay, I'm sorry, I keep saying last one. This really is our last one, I promise. One more example like that and we're finished. Example 7, I guess. I was afraid it was going to be a little bit of a lengthy day. We've got some tricky topics here with these logarithms. If I have that, and it says, by the way, log x equals a, log y equals b, log z equals c. We're going to expand this whole thing out and again make some substitutions when we're finished. So if you would like to pause it and try the expansion on your own, now might be a nice time to do that. And if not, I'm just going to work this through, starting with this big bar for division. So division right away to subtraction. There's a couple things now. This radical needs a 1/2 and I've got multiplication. Again, some students can do a few things at once and other people like to make one line for each thing. These things, again, we might want a parenthesis just to indicate they were all on the top. That 2 that's a power is going to come out front. So now I'm at 2 log x plus log y minus log to the z to the 1/2. And then that 1/2 is also going to drop down. So I think my final answer will be 2 log x plus log y minus 1/2 log z. And now at this point I would make these substitutions from up here. So it's going to be 2a plus b minus 1/2 c. And that would be your final answer. So that's it for log laws. You've got those 3 laws. Good luck with your little worksheet today if you have a little worksheet for practice. And if not, have a great afternoon and I'll see you in class. Thanks, everybody.